All right, we can draw shapes, we can draw text, we can draw images, we can draw animations, but we can't interact with our game yet, which is pretty much the most important part of an actual video game. If you can't interact with it, it's not a game, it's more like a movie. And that's not really that fun in terms of what we're trying to achieve here. So how are we going to do this? First, we need to understand that the Java game engine is capable of two forms of user input. The two most common and obvious forms of user input that we have on all PC games. So things like keyboard and mouse. Now those two input devices haven't really changed in the world of computers for decades. They've been upgraded a little bit in terms of how they interact, whether you're using a trackball or a laser and things like that to track movement, but they're still basically the same thing. A keyboard is meant to get characters into the program. A mouse is meant to track positional data and whether it's been clicked. That's about it. So we're going to use these types of things to interact with our games. Now we're going to keep it simple for this demo, but you can see that you can apply this in pretty much every different situation you can think of. So the first thing we're going to be doing is we're going to start off with a keyboard, because keyboard is definitely a little bit more important. So the question is, where are we going to be detecting our keyboard input? Well, because we want to detect our input roughly 60 times a second, we want to do that inside of the update. We only do two things in the game loop. We update and we draw. And it doesn't make sense to be detecting the input inside of the draw, because that's where we draw. Now, which game state are we in? Well, it could be any game state. It might be the menu, where you're detecting whether the user clicks on a menu option, or whether the user's navigating with arrow keys or something like that. It could be any one of these states. We're going to stick with a gameplay state for now, just to kind of be consistent. So you can see here the description here says, implement standard game logic, input, update game objects, apply physics, etc., etc. But input is the first thing. And the reason being is that we want to start a user's actions immediately as soon as we get that input, because all the other things may be affected by that user's action. So if the user chooses to jump with their character, that might affect something else later on in the input logic, later on in the update logic. So we're going to start there. So before we do that, first thing we're going to need is we're going to need a method to actually do all that work, because we try not to do our work actually inside of the update method. So we're going to create one called update gameplay. So here we're going to say update gameplay. And I'm not sure what variables we're going to need right now. So let's grab the game container and the delta time. So we're going to grab both of them just in case. Now we may use them both, I'm not sure. So down in our code below our draw, we're going to create our private void update gameplay. We're going to have our game container, GC, and we're going to have our delta time, so float delta time. So we're going to use those two things for now. All right, so that's the first step done, and we're halfway there already. So how can we actually get input from the user? How can we detect input? See, the thing is, you have to realize is that not all pieces of software detect every single key on the keyboard, because quite simply, you may not care about most of the keyboards. For example, most video games you play only really care about certain keys, such as like WASD to move. Maybe you have buttons to like change your weapons and things like that. But there's a whole bunch of keys on the keyboard that are not interacted with in the game you're playing. So how do we handle that as programmers? We simply just don't check them. We only check the keys we care about. So for example, if I'm making a very simple game where the only thing the player can do is jump, and the only way they can jump is using the space key, that is the only key I'm going to be looking for. I'm not going to look for anything else. So how do we actually check for a key? Just a simple if statement. So let's say, for example, we want to get find to see if the user pressed the space key. So here's the command: if input dot is key released, and then we just have to specify what key we're looking for. In this case, we're going to look for key event dot vk underscore space. Now the VK stands for virtual keyboard. Okay, and you'd be like, well, what other keys are there? Literally everything you can think of. So maybe you want escape. Oops. Maybe you want just the P key, VK underscore P. Maybe you want the enter key. So it's exactly what you're going to be, what you think it's going to be. It's pretty much it. But if you need a more cohesive or more coherent list, you can go to this website here, which I'll link on our Google Classroom. And what you can see is every key possible listed that you can think of. Quite a lot of them. So the ones that you're really going to want to care about are obviously the letters, but you're also going to care about things like, where is it? Like the number pad. So for people that have a number pad on the right-hand side, because a lot of times we use those for different game-related functionalities. But you can see that we have access to everything. So VK right, that would be your right arrow key. There's also up, down, and left, of course, as well. So these are all the different keys that we have to work with. So going back to our code, we got the space key. And what can we do with that space key? Anything we want. It depends on the type of game we're building. So for example, if I'm making like a platformer game, maybe I need to start a jump animation or something along those lines. So what we're going to do is we're going to say, well, whenever we get the space key, we're going to start the player animating. We're going to start our walker animating. So what we're going to do is take this guy off. So you see how we have this walker start animation? We're going to delete that now. And whenever we hit the space key, we're going to start that animation. Why? Because that's what I'm choosing to do when I hit the space key. So walker image dot start animation. So let's test this theory. We're going to run the program. Hopefully it doesn't take too long. So you can see it's not doing anything. So in order to give the window control, I have to click on it first. And this is a Java thing. It's not a REPL thing. This is actually a Java thing. So we have to click on it to kind of give it focus. So now I'm going to hit the space key, and he's immediately starting to run. Now if I hit the space key again, it's not really, it's resetting the animation. And that may not be something that you actually want. You can see if I hold down that space, or if I tap that space key, it just constantly resets. It's probably not something what you want to do. So what we're going to do is we can play with this. We could say, well, what if he's already animating? Maybe I want to toggle the animation. Maybe I want to turn it off. So in that case, we could do a little bit of extra code to check to see if he's currently animating. So if walker image dot is animating, if that is currently true, then I don't want to start the animation. I want to stop the animation. Stop animation. And else, I want to start the animation. So I'm either turning it on or I'm turning it off based on whether it's currently animating or not. So over here, I hit the space key, hit it again, and he stops. Hit it again, and he starts. Pretty cool. So we've just created control using that space key. Now in this example, all we're doing is starting and stopping animation. You could do whatever you want when that space key is pressed. Now again, you can detect any sorts of keys. Now there's a couple things that you want to keep in mind. You can see that we're using is key released here. What that means is actually you've pressed the key and you've let go of it. When you let go of it, that's when this event is triggered. It's not triggered until that point. There's another option as well called is key down. So as long as that key is down, it's going to trigger this if statement. This if statement is going to be true. So that actually will result in a slightly different thing here. So it's constantly, remember, it's 60 times a second. It's checking to see whether it is currently down or not. So if I hit that space key, I can actually hold this key in and or get different results. I'm not getting exactly what I want because the thing is you're not actually holding that key down for a single update. There's no way that you can press that for 1/60th of a second, which means you might be triggering more than one of these things in one press. So typically speaking, you may want to use it for a hold. So when you're doing is key down, maybe that's you saying, while the player is currently holding the key down, move the character across the screen. But if you want to just kind of trigger some kind of action, chances are you're probably going to be looking for released. Now, in most gameplay, you're going to use a combination of the two. There is no one that's going to take precedence over the other. You might hit released, you might hit down. It depends on what you're trying to do overall. So that's the first little piece of that. So a couple quick notes. As I said, you may actually... you may want to use is key down as well. But another note is when you have a group of actions, Let's say, for example, you're controlling a player on the screen and you want that player to be able to move up, down, left, or right. Now, you got to be careful because depending on how you structure your if statements, you could end up with different results. So let's say you had an if-else if statement. If the user is pressing up, move them up. Else if the user is pressing down, move them down. Else if the user is pressing left, move them left. Else if the user is pressing right, move them right. The thing is, with that structure, you can never be moving more than one direction at a time. So you could never move on a diagonal because it always goes into the first one that's true. So for example, if you were hitting both up and right, because I tested up first, it's going to move up. It's not even going to detect the right. So what if you wanted to have both options available at the same time? Well, instead of using an if-else if statement, you would use separate if statements. So you would have, if the player is pressing the up key, move the character up. If the player is pressing the down key, move the character down. If the player is pressing the right key, move the character right. And if the player is pressing left key, move the character left. So what that means is if both the up and the right were true, that would mean it would move up and to the right at the same time, which would give you visibly a diagonal movement. So we can separate this depending on whether you want a grouped action where only one is possible at a time, or whether you want separate actions where you want all of them possible at the same time. It depends on what kind of game you're building. It completely depends on that. So we'll let you go with that one now. So that is how we can do basic input. Now you can do a lot of things with this. Let's say, for example, I wanted to ask the user for, or I wanted to get some input from the user. So let's create a couple. I'm gonna pause the video for a second. I'm gonna add a little bit of code in here to create some text objects or some text to display it on the screen. Okay. So I've finished putting in the quick changes, and all I really did was I added just two pieces of text. I added a prompt text location, an input text location, and fonts for the same thing, a prompt font and an input font. And I added this variable called month. And the reason why I have this variable called month is the prompt is birth month, and we're just going to get the user to type in their birth month. And that's all there is to it, except for the fact that we have to check the keys that the user types. We actually have to create this string using the keys that the user types. We have to detect every single one of those keys and then add it to that string. So all I'm doing down here is I'm just displaying that birth month prompt, and I'm also displaying the current value of month, whatever that is. So as the user types, I'm going to modify that value. So let's hit stop. And in our update game, I'm going to create another if statement for each one of the keys that I care about. And I'm going to keep it very simple, just to keep it small right now. So let's say, for example, the user hits input.isKeyReleased, and I want to check the keys that I care about. Now, I could go through the entire alphabet. So, for example, key event .vk_a. Get the first letter A. And then if they get the letter A, all I'm going to do is I'm going to add that letter to the current value of month. Month is equal to month plus the letter A. That's it. Just the letter A. And then I could do another one. Now, this is what I was talking about before. I could choose to do separate if statements for the letter B. That would imply that they could hit both the A and the B simultaneously. I don't really want that to be happening as they're typing, because I think what's going to happen is you're going to get people confused. So I'm going to change this to an else if. So that means only one of those letters are going to be detected at once. So just to test this, let's see how this works so far. So we have our birth month, and now I'm going to hit the T key, and nothing happens. How about the A key? Oh, there's my A. And another one. How about B? A. B. C? Nothing. I think I killed it somehow. Anyways, so what we could do is we could just continually add in all the letters for the entire alphabet. And what we're going to end up with is exactly what we'd expect. A keyboard that is constantly updating and checking every single key. Now, this might be a good thing for, like, maybe you're creating a game where the user is doing any form of input, such as like entering their username or whatever type of software you're building. It's completely up to you. So I'm going to leave that there now. I know we have more to this. We could check more birth month stuff, but we're going to just leave it at that point for this moment. Because the next thing I want to do is I want to be able to detect mouse input. Now, mouse input involves one of two things. You can either check the mouse position, or you could check for any form of mouse clicking. Now, we can get the left click, we can get the right click, and we can get the middle click. Middle click means they're basically clicking down on their scroll wheel. We don't have, I haven't implemented the functionality to actually detect the scroll wheel scrolling yet. It's on the docket when there's time, but not yet. So right now we have left click, right click, and mouse position. So let's get the click functionality first. So we want to detect when the user has clicked. Okay, so how do we do that? Well, just like everything else, it's an if statement. And it's a nice short one too. Well, it's a very similar one, I should say, to the other one. So we can detect individual mouse clicks. So if input, goodness here, input.is mouse button released. You can see that it's pretty much exactly the same. Instead of is key release, it's is mouse button release. And now we just have to specify which mouse button it is we're looking for. Input.mouse underscore left. There's also mouse underscore right. And there's also mouse underscore mid. But most people are going to be looking for the left mouse key. So just for now, for testing purposes, whenever they hit the left mouse key, we're gonna change the value of month to February, because that's my birth month. Okay. And let's hit run. So here we go. So if I click on the screen, we get February. So it automatically, no matter how many times I click, it's always going to February though, because that's all we told it to do inside of here. Now we can make it do whatever we want, really. So that's the first thing we can do for mouse button click. We could also do things like tracking the mouse position. Now we could do this only when the mouse is clicked, or we could do it, for example, when at any point. So we could do it live, or we could do it at specific times. So right now, let's do it at a specific time. So I'm going to change this month to its current coordinate. So what we're going to do is whenever the user clicks, I'm going to retrieve the coordinate of the mouse, and then I'm going to display it on the screen so we can actually see where we clicked on the screen. So how do we actually retrieve the coordinate of the mouse? It's not too bad. What we need to do is we need to call a function called getMousePosition. GetMousePosition. Now, when we call this getMousePosition method, so it's input.getMousePosition, that returns a vector 2f. So depending on what we plan on doing in our program, we may need to store it temporarily, like just inside of update gameplay, or if we may be using it in other methods, you may want that to be a global variable that's updated whenever you need to update it. So I'm just going to do it locally in here. So I'm going to create a vector 2f, and I'm just going to call this mousepos. Now it doesn't have a value yet. I'm going to get that right here whenever the user clicks. So mouse position is equal to input.getMouse. Now remember, that's a vector 2f. So I can access the x and y value of that mouse position. So I'm going to do that. I'm going to create a concatenated string of the mouse's current position. So we're going to put a little bracket there to make it look pretty. And we're going to concatenate that to, what is all this mess? We're going to concatenate that to the mouse position dot x. And then we'll add a little comma in between, and we'll concatenate that to the y value, mouse position dot y. And then we'll finish off with a closing bracket. All right. So whenever the user clicks, we retrieve the mouse position, and then we display it in the month variable. Why the month variable? Because that's the only text we have showing up on the screen right now. So let's try running it again. Now it's going to click, and there's our position, 287.0 by 277.0. So let's go up here. We can see it's getting closer and closer to that 0 position. Now this is, oh, look at that. We can see how close we can get. We can almost get right up to 0, 0. Oh, there's 1, 0. Now, we could be clicking anywhere though, and no matter where we click, it's going to constantly do this. Now that's one piece of the puzzle. So we can do this whenever the user clicks and detect that. We could do things like maybe you could take that position and then compare it to, say, for example, buttons on the screen. And if it clicked inside of a button, you could cause whatever action that button is supposed to do, whatever you want to do in that case. Another thing with this, though, is we could actually update that mouse position live. We can do that at any point. So instead of doing this whenever the mouse button is released, I'm going to do it constantly. So I'm going to comment out this if statement. So that means every single update, it's going to get the mouse position and update the month variable. So we're going to see it constantly updating. So we don't even have to click anymore. You can see it's constantly updating. So this is going to be really useful. You could do something like this. If you want to try and position things on the screen at very specific spots, this could help you. And then you could just take away that display for when you're ready to submit your projects and whatnot. See how close we can get to all these little pieces of the puzzle here, okay? So you can see my screen is no longer 800 by 480. You can see it's 775 by 421 because I was playing with my screen size earlier today. All right. So now you can see that we can get a position, we can detect when there's clicks, and using this information, we can achieve certain results, whether, as we said here, that is something like just displaying it on the screen or triggering some kind of action. Maybe the triggering of that explosion. So let's keep that mouse position stuff there, exactly where it is. Actually, we'll move it to up here. But we are going to detect that click. And what we'll do this time is whenever we get that click, we're going to move our explosion to the location of the click. So all we need to do is change the dest_rec of our explode image. So our explode image .dest_rec, I don't want to change the entire part of the dest_rec. I just want to change its position. So I have to do it one piece at a time. Explode image.dest_rec.x is equal to mouse position.x. Now, mouse position.x is a float, so we have to cast this to an integer. Similarly speaking, we have to do the same thing for y. So now, whenever we click our left mouse button, it's going to take this mouse position that we just found, and we're going to change the position of the explode image based on that. So now we're starting to do something a little bit more interesting. Pooh, pooh. You might be like, it's off-centered, but remember, the position of that explosion is its upper left-hand corner. If I want to center it on the image, I could do that. We could hit stop, and we could say, okay, well, that's its position of the top left corner, but I want the middle of the image. So I have to subtract half the width of the image to make it shift over. So we can just subtract here. Minus explode image dot get frame width divided by 2. Or multiplied by 0.5, whichever you want. I'm just going to divide it by 2 for now because it's going to keep it as an integer and then I don't have to do any casting or anything like that. And we can do the same thing for the y value. All right, and we're going to run it, and now it will actually center itself directly on where I click. Right on your head. Boom. You see how it's behind it because we draw the explosion before we draw the walker. How about Mario? Apparently we draw Mario before we draw the explosion. We can test this by looking down here. So there's the player image, then there's the explode image, and then there's the walker image. All right. Okay. So we're going to stop there for now. So now that we know how to detect and actually apply these different abilities, you can start to make an interactive program. It's up to you what you want to do with these things, and it's going to greatly depend on the type of game you plan on building. So in the next video, we're going to be moving on into the idea of moving things around the screen. We're going to be starting from a little bit farther back than what our code currently shows, though, because this stuff is not really technically useful for what we're going to be doing forward. So, as always, good luck and have fun.